Hello everyone, welcome to our channel. So in this video I'm going to tell about the Annova. Annova means it's an analysis of variance. So the meaning of Annova is it is a statistical method. Okay, it is a statistical method that separates observed variance data into different components to use for additional tests. So if you want to test anything, so you can use Annova. So there are two types. One is one-way Annova and two-way Annova. So one-way Annova means it is between groups. Use it when you want to test two groups to see if there's a difference between them. I think it's a simple meaning, you can understand. And two-way Annova. Two-way Annova without replication. Use it when you have one group and you are double testing the same group. So the two-way Annova is the extension of one-way Annova. With a one-way Annova, you have one independent variable affecting the dependent variable. With a two-way Annova, there are two independents. For example, what we can tell, a two-way Annova allows a company to compare a worker productivity based on two independent variables, like such as salary or skills. They both set up compared. These two variables are compared. So it is utilized to observe the interaction between the two factors. Here, two-way Annova is used for the interaction between the two factors and test the effect of two factors at the same time. Effect of two factors, like what I have told, productivity of worker with his salary and skill. Two factors at the same time. At a same time, we are going to compare both. This is two-way Annova. So straight away we move on to the steps of one-way Annova classification steps. So first, what we have to do, we have to set null hypothesis. How to set null hypothesis? So this is the major sentence always we use in a hypothesis setting. So null hypothesis: there is no significant difference between the means of the given sample. This is the first step what we have to do. So first, this is setting of null hypothesis. So under this first step, sum of squares of variations between samples, that will take in columns, that is SSC. SSC means sum of squares of variations between samples. So in that, first obtain the mean of each sample. We have to obtain the mean for the given sample. So next, second, find the means of sample means, that is grand mean. We have to find grand mean. Next, C, find the deviations of sample means from the grand mean. What we have calculated the sample means, we have to find deviation from the grand mean. So next, D, square these deviations and multiply by the number of items in the samples. This is the D step. And E, find the sum. When we find, we'll get SSC. So next, we have to divide SSC by the degrees of freedom. Degrees of freedom is it's C minus 1. This is MSC. When we divide, we'll get MSC. MSC means mean sum of squares of columns. So the formula for MSC is equals to SSC divided by C minus 1. As I told, SSC means sum of squares of columns, and C minus 1 is it's a degrees of freedom. So next, move on to second step. Sum of squares of variations within a sample. Within a sample, we have to find the variations. So that is SSE. SSE means sum of squares of error. We have to find. Under that, A, find the mean of the sample. First, we have to find mean of the sample. And B, find the deviation for the various items of the sample from the mean value. With the mean help of value, we have to find the deviations. So next, C, square these deviations and obtain their sum. We have to obtain the sum with the by squaring the deviation. So next, D, repeat this process for all the samples. So we have to repeat for all samples. So next, E, find the sum of squares of the deviations of various samples, that is SSE. Then we have to divide F step. We have to divide SSC by the degrees of freedom, which would be degrees of freedom. What will be here? N1 minus 1 plus n2 minus 1 plus n3 minus 1 up to nth. How many nth value will be there? We have to do up to there. So this would be MSE. MSE means mean square of errors. So next we have to find F ratio. How to find F ratio? That is MSC divided by MSE. That is mean square of columns divided by mean square of errors. So I think you'll come to know when I'll take a problem and explain this. Just you have to by heart or understand the steps. Next, after the last, we have to do Annova table. Just we have to present the data in the Annova table. That is squares of variations, sum of squares, degrees of freedom, mean sum of squares, and F ratio. So this is the table how we will present. So here between the samples columns and within the sample columns, that is SSE value what we calculated in the problems, we have to write here, and SSE here degrees of freedom C1 is 1 and another degrees of freedom n minus 1, and MSC and MSE, and F ratio what we will calculate the formula MSC and MSE. So you'll get to know how it is when I take a problem. So for more videos, subscribe to our channel, and if you have any doubt, you can comment in a comment box. Thank you.